Welcome to 6.5, dividing polynomials. We're going to start by looking at the evaluation of polynomial function using synthetic substitution. Before we talk about synthetic substitution, let's do a direct substitution that we're familiar with. So to find p of -2, I plug in the value. You get 4 -2x cubed plus 3 -2 squared plus 2 -2 plus 1. And if you work through the calculation, that should come out to 23. Okay. Having seen that, let's go through the synthetic substitution. And the way we do that is to have the input value, -2, on the side like this, thusly. And then we would write down the coefficients of individual terms, 4, 3, 2, 1. Make sure that this is in a descending order, make sure that this is in a general form. Okay, guys? So when you do that, that's 4, 3, 2, and 1. And let me get rid of this right here. That's unsightly. And the way this thing works is you bring down the number 4, and then what you would do is you multiply the number here. -2 times 4 gives you -8. See that right there, guys? -8. And then when you combine them, that gives you -5. And then to go up here, you multiply by -2, which will give you 10. And you come down by adding these two values, which is 12. You multiply these two again, and which gives you -24. And then you get -23. So this right here, that is equal to p of -2, right? Is equal to -23. So the process of doing that is called synthetic substitution. Now, another skill set we have to learn is dividing polynomial using long division. And this works exactly the way the long division works. Let's do a long division, shall we? What if you had number 29 divided by 6? The first thing you ask yourself is, does 6 goes into 2? Answer is no. So you don't put anything. You move on to the next number. Does 6 go to 29? Answer is yes, it's 4. When you do that, 6 times 4 is 24, and then we would subtract, don't we? And that is 5. Does 6 go into 5? Answer is no, so my remainder is 5. So what we could say is, therefore, 29 is equal to 6 times 4 plus 5. So this right here is a divisor, and this here is the quotient. Quotient is the value that you get, number of times that number goes into, right? The divisor goes into a number, and that right there is the remainder. Okay? All right, guys, let's try a problem here. So this is being number that's being divided by. This is the factor right here. That's the divisor. X squared plus 3x plus 1, and that's 4x cubed plus 2x squared plus 3x plus 5. Once again, this has to be in a descending form, right? Or simply general form. You ask yourself this question, guys. The only thing that you have to worry about is the leading terms for both the divisor and the polynomial that you're dividing into. So the question is, how many times does x squared go into 4x cubed? In other words, what times 4x squared gives you 4x cubed? And that is 4x. So that'll be 4x cubed plus 12x squared plus 4x. And just like this over here, we will subtract them. This has to cancel because that's why we chose them in the first place. So 2 minus 12 gives you 10x squared. 3 minus 4 gives you -x, and you bring that down, you get 5. So next question is, x squared times what gives you -10x squared? and that is negative 10. That gives you negative 10 x squared minus 30x minus 10, and we subtract them. When we do, negative 1 minus 30 gives you 29x. 5 minus 10 is 15. And we're done. So this right here is what we call the quotient. This is the remainder. And this right here is the divisor, d. And this right here is the polynomial. Okay? So what some books will write this as is just like over here, guys. P of x is equal to q of x, that's the quotient value, and the divisor, d of x, plus the remainder, r of x. Because each term may be expressed in terms of x. And then the direction might say, once you've done doing the long division, express this in terms of this right here. So we could say that p of x is equal to, let's put the divisor first, right? Let's switch these two. Sorry. That's 4x minus 10 times the divisor. You know what? Sorry. Just let's keep it as it is. Q of x is that, and d of x is x squared plus 3x plus 1 plus, and that's 29x plus 15. There you go. Therefore. Yay. Okay, moving on to the next question. So we are dividing p of x by x minus a using synthetic division. Okay, but before we do that, I would like to compare long division versus synthetic division, synthetic substitution method. In this case, that should really be referred to as division. Right? Okay, let's look at the long division of this first. So we have 3x cubed. We don't have any x squares, so you need to leave a space, right? Plus 10x plus 20. So this empty spot is a place where we would have had x squared. You could choose to put 0x squared if you like, but I am choosing not to. So in this case, x minus 2. If you're wondering why, I think it just looks cleaner. It's less clutter. Okay. So we do what we did earlier, which is what happens over here, guys. Well, x goes into 3x cubed how many times? In other words, x times what gives you this? 3x squared, right? And you multiply this to these two, which will give you 3x cubed minus 6x squared. And we're going to subtract that, just like before. This would cancel. That's the reason why we chose this number in the first place, right? So we end up with 6x squared. We're going to bring these two down. 10x plus 20. So x goes into that how many times? If you said plus 6x, then you're right. That would be 6x squared minus 12x, and you subtract. And when you do that, that cancels, and that becomes 22x, bring that down, plus 20. X goes to 22x how many times? And that is 22. And that is minus 20, minus, that should be 22x minus 44. That cancels. 20 minus 40 gives you 64. Wow, it just fits in just right. Okay, let's try synthetic division. Now, that right there was not a mistake, because synthetic division, you do it exactly the same as you guessed it, synthetic substitution. All right, so what do? We copy these numbers down, just like this over here, guys. That's 3, but I don't have a square, so I put a 0x squared, 10x plus 20. And the way we got to do it is slightly different. Okay, you got to solve for, you see this value right there, guys? You have to solve for x. Set equal to 0, then x is 2, right? That's the number that we want right here, 2. That's the value that you will substitute in, right? All right, So that's a new thing over here, but just keep that in mind. The rest is the same. Bring down to 3. What do you get? Well, I get 3. Then you multiply 2 and 3, you get 6. You bring it down, you get 6. 2 times 6 gives you 12. You bring it down, I get 22. You multiply these two together, it's 44. To go this way. Every time you go this way, you multiply it by this value right there. Okay? Adding these two, we get 64. Oh wow, look at this. What I noticed was that number 3 matches this number right here. 3 and this right here. Or even this, right? 6 right here matched the 2 6s right there. 22 over here matched the 222 over here. 64 matched this number. So essentially, I'll go with this number right there, right? So synthetic division does the same thing that long division does without the need to write down all the variables. You just write down the leading coefficients of each right here. So what that means is that you draw a line over here, and this right here represents the q of x, the coefficients of q of x. But you have to understand though, when x goes into x squared, the first one has to be x squared. This is x, and this is just a coefficient, constant term. And this right there is the remainder. Okay? All right. I hope you got that. Let's learn a couple of theorems. The remainder theorem says remainder of the division of the polynomial p of x by linear polynomial x minus a is equal to, oops, typo, that should be p of a, right? Because that's just like the one that we did earlier. Right here, guys, right? If you just plug in the value, minus 2, that value that we got, that's a remainder. Okay? And the factor theorem says if, sorry, this should be a again. Okay, that was a typo again. That a linear polynomial x minus a is a factor of the polynomial p of x if p of a is equal to 0. Right. That makes sense, right? If the remainder is equal to 0, whatever you divided by is now a factor. Okay. So, using remainder and factor theorem, let's try to do this problem, guys. Okay. The question is, determine whether the given binomial is a factor, this binomial, of this. How would we know that? We would know that if the remainder is equal to 0. So guess what we're going to do? We're going to be using synthetic division. Let's do synthetic division. So the way we do that is x plus 3 is equal to 0, that is x equal to negative 3, right? So we put negative 3 on this corner. And my coefficients, I'll make sure that there are no empty spots. That's cube squared first, and then we got the constant term. So that's good. All right, guys. So we got 1, 3, negative 4, and negative 12. Why don't you guys go ahead, like usual, do this ahead of me. Pause the video. Okay. So we're bringing the 1 down, multiply these 2, I get negative 3. Add these 2, I get 0. Every time I want to go diagonally across this way, guys, I always multiply by this number here, right? And negative 3 times 0 is 0. When you add this 2, negative 4, to go here you multiply, that gets 12, and that's a 0. Remember, this is the remainder, right? And this is a q of x. Oh, wow. So what we could say is that since p of negative 3 is equal to 0, we could say that x plus 3 is a factor of p of x. That's right here. And we need to justify it, right? What's the reason? By factor theorem. That's what factor theorem says, right? So the remaining factor that they're asking is in fact the q of x, right? So to answer that question, yes, the remaining factor, which is q of x, is equal to, that has to be, when you divide x cubed, it becomes x squared, is x squared minus 4. But we're not done actually, because it wants to find remaining, I should have said factors. Question is that factorable? And answer is yes. So that is equal to x plus 2 times x minus 2. Now, even though this question didn't ask for it, if the question did ask for it, if it wanted you to factor p of x completely, using synthetic division is one way to factor, right? So we could say that, this is beyond, right? If the question said factor p of x, right here. So using all these methods, we could say that p of x is equal to the divisor, which is this, x plus 3, the q of x is that, plus 0, because the remainder is 0. All right, guys, that wraps out the lesson for this, and we'll go over any questions that you might have and wrap up this chapter. And have a good night.